submit all the finals and stuff. I just realized I can't full screen this. Oh, here we go. Nice. Yeah, so today we're going to talk about OAuth. What is an OAuth provider, why you may want one in your life, or multiple, or yeah. And then I'll also talk about the practical application I did about OAuth working for DESI, which is like a research group at LBL up the hill. So a bit about me, I'm a senior undergraduate student, computer science student studying at UC Berkeley, probably why I'm here at the club. And I've been working with the DESI team since I was a freshman through URAP. So right now I've worked with them for like 3 years, a variety of computer science stuff. It's actually an astronomy team, but I worked with performance optimization of Python code, web development, and also most recently security, which is what I'll be talking about today. So what is DESI? Well, DESI is an acronym for Dark Energy Spectroscopic Instrument. Our goal is to build the largest 3D map of the universe to date using robots and fibers. So specifically, we have like a big instrument installed on top of this telescope, and then it has 5,000 different robotic hands controlling 5,000 different fibers to pinpoint the exact positions on the night sky of a particular galaxy, for example. And we do it in parallel, so we're very efficient compared to previous approaches. So this is an example of what the instrument would see on the sky. And then once we point our fibers to those galaxies, for example, then we can measure their redshift, which is useful for validating models for dark energy, which I basically don't understand. I'm just here to do computer science, but it's very cool. All right, so part one, I'm gonna start with a brief introduction of what is the OAuth protocol and what is OpenID Connect, and why you might want them in your life. So first of all, there is a differentiation between, or distinction between authentication and authorization. So authentication means that verifying and linking a user to a particular identity. So for example, when you sign in with Google on some third-party website, you're asking Google to do authentication for that website. And afterwards, if you sign in successfully, that website can tell from Google that you're the user that you're claiming you are, or Google claims you are. This is authentication. And then authorization is something slightly different. That is granting permission to a resource that the user controls. In this case, it almost always requires authentication to happen first, because without knowing who the user are or who the user is, we don't know what resources the user actually has. An example of this would be, would you like to allow app X to access your emails on Gmail? So this is an example of authorization. Okay, so what is OAuth? This is very succinct. It is just an open standard for authorization. It's a protocol that describes how you can do authorization on the web security. This is a quote from a guy from Okta, I guess. And then as an example of OAuth in action for performing authorization, as you can see, here is a screenshot of me trying to allow Greatscope to access my Git repos. So Greatscope sends me to GitHub saying, this user may want to authorize me, which is Greatscope, to access his account's repos. And the GitHub would ask me if I want to actually allow that, and then send me back to Greatscope, either if I accept the request or deny it. So that's the idea for OAuth. But that leads us to a question. What about authentication? So the OAuth protocol does not specify an interoperable way to perform authentication. And for some time, websites did invent their own token formats for attesting to user identities. So for example, Facebook had its own format that developers of third-party websites who want to use Facebook as an identity provider had to write code that reads from Facebook's proprietary format. So afterwards, people realized this is probably a bad idea, so let's have something that's interoperable. And then we have OpenID Connect. It is invented on top of OAuth, so it has all the protocols and infrastructures of OAuth, but it now specified the format of an ID token and how to sign these ID tokens. So anyone with an ID token with the appropriate public keys can verify that it is valid and it came from where, so that we can be sure of that some entity has said this user is the user you're looking for. Okay, and from this point onwards in the stack, I'll use OAuth to mean both OAuth and OIDC, because these days it's very rare to use OAuth on its own. It's usually a combination of both. Okay, and then as I mentioned, OIDC defined. Did that just work? Okay. Sorry about that. Let's continue. So as I mentioned, OIDC defined a token format. What is it? Well, it turns out it's very useful in security. It's called a JSON Web Token. And it basically has three parts. The first part is the header, which defines what signing algorithm is used by this token. The second part is the payload, which describes something. It's just a JSON. So it could be user info, could be something else. Though in the case of OIDC, it's exclusively user info almost, but JWTs can be used as like a generalized signed data format. And then finally, there is the signature, which would allow you to verify that this has not been tampered with. So this is a very useful format, not just for OAuth and OIDC, but also for other stuff, including CTF. So for example, the web question boiler CTF that we did a couple of weeks back required some knowledge of how to construct a JSON web token. So good to know about it. And then there is a very handy JWT.io that allows you to decode the JSON web token and then also sign it with different keys, which is very convenient when you're doing a CTF. Yeah, okay. And then finally, there is the concept of an OAuth provider versus an OAuth client. So for an OAuth provider, it is essentially the service that provides authentication and authorization for users. So think of Google or GitHub in our previous example, trying to allow great scope from accessing my repos. And then an OAuth client is any app that either wants to retrieve users' identity or wants to request access to a user's resources. So in that previous example, it is great scope. Okay, finally, we're at the benefits of OAuth. Why would you want to use it? Well, the most important thing, I guess, at least in my opinion, is that apps don't need to store and verify user passwords. It is a big headache to store them, to make sure that they're hashed and salted properly. There are frameworks that help you do that, and they're very convenient. But it's better to just delegate this responsibility to someone else who are potentially more professional, like Google, if you can. So that's the biggest benefit. But OAuth is also very important because it can grant apps resource permissions in a granular fashion, and then also allow the users to revoke it at any time. So say if you want to just, say if you just want to allow some app to read your email inbox, but not to delete stuff or not to send new emails, this is very useful. And with that, I'll take a brief pause and take some questions, if there are any. Yes.
Could you reiterate maybe the problem with like you were saying how this came to be was like companies needed to read from like Facebook's proprietary framework. Could you like maybe reiterate what you were saying right there?
Oh yeah, for sure. So basically, OAuth provided a way of apps to specify to each other what resources have a person granted, right? But then to also provide the person's identity along with that information. So for example, this person's name is this and email is this. Companies have to invent their own formats.
Okay.
So in this case, OIDC said, let's all use JSON web tokens and sign it with these algorithms.
Got it.
Yeah. Other questions? Okay, awesome. Let's move on. So in part two, I'll talk about a particular application that I did using OAuth at DESI, which is somewhat an unusual one, and you'll see why. So I started with a problem statement. So here is the problem we're going to solve. So first of all, we have a wiki service that every user has an account for. It's essentially how we collaborate. We put our documents on there. And then there are also lots of other additional web services that we want to secure. So that includes a file server, that includes a Flask app called the Nightwatch, that includes a Grafana instance, et cetera, et cetera. Because our wiki service does not like offer OAuth or any interoperable authentication mechanism, it is kind of hard to also authenticate the other web services. Another one of our goals of doing all of this is that we want to provide minimal to no friction for existing users to continue their work. After all, DESI exists DESI's goal is for scientists to do research on dark energy. We don't want to hinder their research in any way, if we can. And then finally, we only need authentication, but not authorization. So essentially, we have some apps that we want to verify that the user is a collaborator at DESI, but we don't currently have apps that want to access other apps' information, which would fall into authorization. So yeah, here's our problem statement. And then what can we do? Well, the most obvious solution and probably the most modern one is to use an existing large OAuth provider, for example, like Google or GitHub, and then just put it in front of everything we serve. So its pros are very obvious in that it's most secure and simple to set up. But why not choose this option? Well, there are a couple of cons. One of them is that we need to require everyone to register for new accounts or potentially reuse their personal or institutional account for this. And because DESI is a very large organization with hundreds of scientists, this could be a lot of hassle for both the people organizing this and then people who have to keep track of additional accounts. So essentially, if we account for this account and then also the previous wiki account, we now have 2 accounts for DESI for each user. So that's not the most ideal solution we thought. Can we make this slightly better? So solution 1.5 is to use an existing large OAuth provider, but then install an OAuth plugin for the wiki. It is probably as secure as the previous solution. And then we also have one account for all DESI services, yay. But the problem with that is that first of all, again, still need to require everyone to register a new account, which is additional time investment on scientists. And then this may cause a downtime to the mission critical DESI wiki, which we definitely do not want. Because we have to modify it to, instead of using our old authentication mechanism, install a plugin so that it actually uses OAuth. So unfortunately, this is not particularly ideal either. Another solution, somewhat very different, is that let's just use the raw password database from the wiki for other services. Now, you may, as you can see, this is probably a very bad idea. Well, although the pros is that we do have one account for all DESI services, well, the cons are that we potentially have to expose the password database to the internet. Of course, we'll set up all the authentication stuff, but if we can keep it local, that would be great. And then finally, we potentially have to allow all DESI web apps to access this password database hash to compare with it when the user attempts to log in. So in that case, well, that means if there is a vulnerability to any of our web apps, which is very plausible, then the attacker could have all the passwords in transit. Okay, so this brings us to solution 3, which is the solution I'm going to mainly talk about today. That is to implement our own OAuth provider that verifies the password with the wiki via HTTPS. What does that mean? Well, basically it constructs a post request to the wiki and then inspects the output, seeing whether the login succeeded or not. The pros for this approach are that we have one account for DESI services again. does not require modifying the wiki anyway, so we can minimize the downtime. And then finally, only the OAuth provider itself has access to raw user passwords. And plus, we don't store it anywhere. It's only in transit and in memory. It is relatively safer than our previous solution, which is number 2. The cons is that we have to write a bunch of code for this, but it turns out we actually didn't have to write that much code, thanks to open source projects. So yeah, any questions so far? Nigel?
Just curious, what kind of wiki service are you guys using?
It's called TrackWiki. Not sure if you've heard of it. Yeah, it is fine. Not super modern, but
And it's like locally hosted and everything.
yeah, hosted I'll be on everything. Cool. Yeah, so thus we decided to build our own auth thread, which I guess is not something people typically do. Enter Ori Hydra. This saved us a lot of headache because without Ori Hydra, I don't know if we will decide to go this route. It is an open source framework for implementing your own OAuth provider, and it does not store passwords. So it talks to another service called a login provider in their terminology that you have to implement yourself to accept or deny particular login or resource requests. And because we don't have authorization for it, like I said before, we only really accept or deny login requests. And here's like a diagram of how this would look like. So there's an Nginx in the front that exposes these two services to the internet. And then this login provider talks to Hydra when there is an incoming request. And then also talks to the user asking for a password. And then finally communicates with the wiki via an HTTP post request to actually verify the password is correct. And then finally, the login provider tells Hydra either the password is correct or not. And then Hydra can take action as a normal OAuth provider. Okay. So this is sort of the OAuth infrastructure side. We also have our normal web apps. How do we set this up? So usually what we do at our group is that we have a web app that is behind the Nginx as a reverse proxy again. So Nginx is a popular web server that we use as reverse proxy. And unfortunately, it does not provide a module to act as an OAuth client. So recall that OAuth client is an application that either wants to retrieve users' info or request some resources permission. Okay, so but fortunately, there is another open source project called Vouch Proxy, which is an OAuth client that conforms to Nginx's auth request protocol, and we can use that as an OAuth client instead. Okay. So here is the full deployment diagram. So in the happy case, when the user goes to Nginx, it first sends a request to Vouch Proxy with the same cookies and stuff. So Vouch Proxy knows whether the user has been authenticated before. And in the happy case, the user has. So Vouch Proxy says, okay, this request is valid. Nginx forwards the user to the protected web app and everything goes well. Otherwise, if Vouch Proxy couldn't find the cookie, or if the cookie is expired, or if it's invalid, then it first of all tells Nginx to redirect the user to Hydra instead, which through a series of callbacks, eventually goes back to Vouch Proxy with the result of whether the user successfully authenticated or not. And that is essentially it. Now, as for some future directions, so DESI will eventually fulfill its responsibility of advancing our knowledge of the universe to the best of its ability until a more advanced instrument comes along. So it will eventually retire and the collaboration will dissolve. But the same people probably would still go to a similar collaboration with the bigger and better instrument. So moving forward for the new collaboration, we probably should either require everyone to register an account with a major OAuth provider at the very start so that we don't have to worry about this two-account business. or host something of our own, which is like, for example, Keycloak. I'm actually not aware of any good alternatives to Keycloak, so if you know, please let me know. That would be great. And then we'll also use a wiki that supports OAuth from the very start, so we don't have like a separate wiki password for everyone. And then finally, we'll probably keep using Nginx and Vouch Proxy because it's a good combination for enforcing OAuth at the very start of the request. But we'll probably sunset Hydra because now we no longer have the requirement or the need to verify with the wiki in a weird way that we are doing right now. Well, I guess I shouldn't say we're doing right now. This is currently still just deployed in a test environment, and we have not done a full security audit yet. So if you have any suggestions, which are extremely welcome today, then we can work that into the design. Okay, so some random closing files completely not related to this OAuth, but OAuth in general. Here's why you may not always want to use OAuth for authentication. It's like throughout the talk, I've been saying how great OAuth is, and indeed it is great. But the problem with that is major OAuth providers can terminate your account at any time. Typically, this applies to all the major OAuth providers. So an example I'm using here is Google. On the screenshot on the right, this is a developer for the popular video game Terraria. And he was working with Google to get his app on Google Stadia, but then for some reason, his Google account got disabled. So he had to work with Google through many either official or unofficial means, but still couldn't get it resolved. So in the end, he was very angry and said on Twitter that we're burning this bridge and then consider the bridge burned, blah, blah, blah. I will not put Terraria on Stadia. So yeah, so even for this person, it's very hard to get his account back. So, well, as a normal person, I don't think, or I don't expect myself to get my account back if Google does decide to ban me for whatever reason. And if I were to use a Google account for every single website that supports OAuth, it could be problematic because I would lose access to all of them. Therefore, having a locally backed up password manager is probably the best practice. Though for authorization, you still have to use OAuth because it's typically authorizing a resource that, for example, Google controls anyway. So it makes sense that you have to use Google, for example. But yeah, I think this is at the end of my talk. So questions, concerns, what are your thoughts? Did you spot a vulnerability? And some suggestions to improve would be awesome. Yes.
Just for clarification, what's the role of Hydra in this case?
Yeah, excellent question. So moving back a little bit, this is probably the easiest. So Hydra is like the OAuth framework. It handles all the intricacies of the OAuth protocol, whereas the login provider is a simple app that only knows how to show a login page, and then also how to verify with the wiki, and then talk to Hydra.
And you wrote in Hydra, you wrote like a custom thing that detects whether someone's logged in or not, depending on the information you got from the login provider.
Actually, this is all standardized within Hydra, so I didn't have to modify Hydra at all. Hydra sort of defines a set of APIs that you can call from the login provider to either accept or deny a login request. Yeah. Which is very clean so that we have a separate thing that we maintain as opposed to having to branch off of Hydra. Great questions. Others? Or vulnerabilities? I'll be very interested.
Seems like it's only as secure as the wiki is, and given how old you're saying it is, that seems like it might be a point of concern.
Oh yeah, I definitely agree. So if we can replace the wiki, we'll definitely do it today. But unfortunately, yeah, that's part of the constraints.
I don't know if it's relevant, but I've seen companies use Atlassian for their internal wiki. And it seemed to me that, they had some sort of a lot of integration with other like custom written applications. But I'm not too sure how it works under the hood.
I see, I see. Yeah, that's a good point. I do think that HCN has its own OAuth implementation, which is definitely a possibility we should look into. Given the sufficient funds, I guess it really depends on how much money we get for our next instrument. That's a good point. Anyone online, I guess? Okay, anyway, oh, go ahead, Paul. Oh. Yeah, so if we don't have any other questions, well, if you do at any point in time, please do email me. My email is markz@berkeley.edu. I would be very happy to chat, or like anything general and secure. I'm very interested. Okay. Yeah, thank you so much for attending. Good luck on your finals. It's been a busy week, so I really appreciate it.
And this is your last Berkeley meeting.
Yeah, essentially, I'll be graduating, unfortunately. I'll miss this place.
Congrats.
Thank you. Thank you.
I had a couple announcements unless you have any. That's it.
No, that'll be it. I'll skip to the next one. Cool.
Okay. So only one of you here actually participated in lockdown. That was Mark. But then there were a couple other people that were there too. And this was a defense CTF lockdown that we participated in. And I think registration started like earlier this semester. So if y'all like missed it or started coming later in the semester, probably didn't get the memo that this was happening. But we got 6th place, and this was our first defense CTF. So yeah. And it was pretty cool. And the basic idea of it is you have a bunch of services, and there's a red team trying to actively attack the services that you manage. And then you have to do a bunch of stuff to try to secure it. And if you look over here, I believe we were team 8.
I think 11.
11? Okay. All right. That's pretty funny. Okay. Yeah. So team 11 seems like at this moment in time, we had all of our services up, and team 8 had all their services down, which was pretty funny. So I guess we screenshotted that. But yeah, cool. Hopefully we get 1st place next year, but that was really cool. Okay. So some cool little things happening over the summer. We have 3 very popular conferences happening: DEF CON, Black Hat, and RSA. And these are basically, if you're not too aware, these are this is basically where the current edge of cybersecurity and then the community gathers and like share presentations, workshops, and different things. A bunch of companies come through, and then you can network with them, and it's generally a really great time. I'm saying this, I haven't even been to any of these, but from what I hear from the people that actually went, it's a really great time. Get to learn a lot of stuff, and it's just a great way to get involved with the cybersecurity community. And the most important one is DEF CON, which is happening from August 11th to August 14th in Las Vegas. But there are also some local ones happening here as well. There's RSA happening in June 6th, and B-Side San Francisco, which is a little bit smaller, but also really great in itself, happening from June 4th to June 5th. So generally, there is some kind of student discount for maybe like B-Sides, and it's free for RSA if you're a college student. I don't think DEF CON holds any discounts. No? Okay, yeah. But if any of you guys are interning somewhere or joining a company, talk to the security team. Most likely they'll be going to one of these conferences and try to snag a free trip over there, because your company definitely can afford to do that. But if not, make sure you have cash ready on hand and go over there, have a great time. Okay, and there's some CTFs happening over the summer, so it's not completely dead. First of all, there are some 24/7 CTFs. You can also call them war games. So there are some pretty good ones that
to me were very helpful. So pwnable.kr is a great CTF that you guys can try out, which teaches you a lot of binary exploitation, reverse engineering, and stuff like that. Hack the Box EU. I've mentioned it probably a bunch of times, but you basically have a bunch of boxes, try to secure, try to attack it, stuff like that, and over the wire, which I have tried out. But these are really great resources for you guys to learn. And there's some pretty cool CTFs happening over the summer as well. There's Google CTF, UIUC CTF, and then Crypto CTF, which are probably the 3 ones that I've heard about the most that happened over the summer. So definitely try those out. We can even, like, if you guys are interested, I'll send out announcements on the Discord and we can compete remotely over the summer. It would be a really good time. But if not, you could always compete solo or find some friends to compete with. And registration is really easy. There's not much startup costs involved in doing these. And if you want to look at the schedule on ctftime.com, there's a whole bunch of CTFs happening over the summer. Just click on any one of those, and the list is growing more and more as we get closer to summer. So learning never stops. Okay, so that's basically it. This is like the final meeting of spring 2022. Thank you all for showing up and participating in some of the events if you have. I know this has been pretty disorganized and the workshops don't work 90% of the time, but I'm definitely trying to improve that by next semester. We did start at a pretty awkward time during the middle of the semester, so I do really appreciate you guys coming out and attending the meetings. And I promise next semester will be better because we'll have more time to prepare for everything. But yeah, over the summer, do some CTFs. If you guys are interested in running one, just hit us up on Discord, and then we could probably get something going. Attend conferences, and make sure talk to the security teams wherever you go over the summer. Or if you're not going anywhere for in terms of a company or an internship, whatever, do some security oriented projects because these are really great for learning. You can try to mod a video game, you can build a home lab, and draw stacks. But basically, ask for help, ask any questions you have on the Discord. So we'll be very active over the summer, and I'll definitely be watching it. And yeah, I'll also be posting some learning resources if you guys are interested on the Discord as well. So you guys have something to do over the summer. Yeah,